Starting on number 9, it says, suppose you have an electric scooter that has a max battery capacity of 200 kilowatt hours. Each mile you drive leaves it at 75% of its previous battery life. How many kilowatt hours of charge will be left with after 4 miles? So, when I'm looking at this, I know with percentages I'm multiplying, so I'm working with a geometric again. And each mile you drive leaves it at 75%. So each time I'm going to multiply by 0.75. And here's a point that people get confused on sometimes. It's like, why am I not subtracting 75%? Why am I not adding 75%? Because in this case, it just says that it leaves it at that. So after a mile passes, I've got 75% of what I had. If it said each mile it decreased by 75%, I would be subtracting by that amount. Like I would do 100% minus 25%. Minus 75% gives me 25%. I would subtract it, but it just says I'm left with that much, so my ratio is 0.75. And notice this is after I have driven a mile. So this 200 would be my zero term, because I'm at 200 kilowatt hours before any time has passed or any miles have passed. Nothing has happened yet. So my function, or you can write it as A of n, don't really matter, would be 200, 0.75 to the n. If I wanted to know how much it had after 4 miles, I could just plug in 4. So f of 4 equals 200. 0.75 to the fourth. Type it in my calculator. This is round to the nearest tenth, so I go 200, 0.75 to the fourth, and rounded to the nearest tenth. That would give me 63.3 kilowatt hours. So a teacher at Made Up County makes $35,000 during their first year of the job. Each year they receive a 6% raise. So good example already. This another percentage question that works a little bit differently. How much do they make after? And this should say make in total. How much do they make in total after 4 years on the job? How much do they make in total after 4 years on the job? So they get a 6% raise. So they originally had 100% of their money, and then each year they get an additional, additional 6%. So they're at 106%, which is 1.06. That's why I'm adding, because they get a raise on top of whatever they already had. They don't just get 6% of their money. That would be a horrible job. They get 6% more than what they had. So, and also this $35,000 is after, obviously I have to work a full year to get my salary. So this would be term 1 and not term 0. A year has passed, like I have to do a year's worth of work to get that $35,000. So I would just write it out as $35,000, and to get to the next point, I would multiply by 1.06, so 35,000 times 1.06. Do it again. Okay, and because it wants to know how much I have in total after these first 4 years, like how much they've made in total, you would just add all of these up. So add all of these up in your calculator. So they would have made that much total after 4 years. for each of the following functions. So I've got f of x and g of x separately. I know it didn't separate very well. Delta Math does it every time I try to print something from it. It wants to label it as growth or decay and identify the percent of growth or decay. So right here, if it's bigger than 1, it's growth, and if it's a decimal, it's a decimal, it's decay. So here, between I'm bigger than 1, sorry, I am working with growth. And originally I started at 1 for 100%, and I went up 56%. So that is telling me I went up 56%. So I had a growth of 56%. And then here, originally, I'm looking at 100%, and I'm under 1. So I fall in this decay category. So I am decaying. And how much did I go down? Well, if I'm left at 87%, that means I've decayed by 13%, because 100 minus 87 equals 13. And then what are the left and right hand limits of the functions? So remember, with this being growth, my function is increasing. And because this is decay, so it's decreasing. And with exponential functions, you're always going to have a horizontal asymptote. And we talked about this last week, or I guess the week of November 27th to December 1st. Like during that week, we talked about it's usually written in this form, a times b to the x plus c, and this part at the end is talking about your horizontal asymptote. But here on both of these, it's just plus 0. So I've got a horizontal asymptote at y equals 0 for both. Okay, and that's important for my function here. So if I think about what's happening on these functions, this is my y-intercept. This is my y-intercept, because when my function isn't shifted any, my initial value is going to be the same as my y-intercept. So if I drew this out, I would cross at 13. And I know that my function, and it's not going to be an exact graph, but I know my function is decreasing if it's decaying. So on the left side, I'm at limit as x goes to negative infinity. I'm going to infinity, and right here, I'm getting closer to 0. That's what that horizontal asymptote's doing. Of g of x, I should say. It's on me. Getting ahead of myself here. So that is 0, rather. It's on me. So as I go left forever, I'm going to infinity. As I go right forever, I'm going to 0. And then for f of x, I'll do it in red. I'm increasing because I'm growth. I'm increasing. I'm crossing at 20. And so on this left side, I'm going to 0, and then on the right side, I'm going to infinity, okay? So this is what it's assuming everything, like I have positive values in front. It's always, for increasing, it's always going to look like this, and for decreasing, the limits are always going to be like this. Now on 13, it wants us to write it, rewrite f of x into this form, and basically it says just get x by itself. So this is where knowing those exponent rules comes into play. Addition can, subtraction or addition can be broken into multiplication for the same base. So I can write this as 2 to the x times 2 to the negative 8. And then just evaluate 2 to the negative 8 in my calculator. Math enter to get that as a fraction. So this would actually give me 1 over 256. So I'm getting this just by evaluating this part. And then just rewriting this in 2 to the x. So talking about the transformations, what are the transformations that take f of x to g of x? So originally, remember, this 4 doesn't do anything. This is just part of the parent function. 4 to the x is the parent function in this case. So if I look here, this in front is a vertical reflection. My exponent is a liar, like a parenthesis. It's a liar. So instead of going right 3, I'm going left 3. And then, like normal, this is down 2. There's that chart in your notes on lesson 1 of the lesson 4s that I have all the transformation rules. And then 15, this is one of the weirder ones. This is, I have to use the most important formula for this is f of x equals a times b to the x. That's the normal kind of base standard form for these exponential functions. So I'm going to use this function and kind of create something similar to a system of equations. Okay, what do I mean by this? Well, I'm going to plug in, this is my x value, and this is my f of x value, my y value. Because remember, f of x is the same thing as y. So my f of x value, I'm just going to replace here what I know. I know my f of x value is 3. I don't know a, I don't know b, but I know my x value is that. So right here, I'll highlight to show you where I'm putting everything. Okay, I just plugged in my x and y values, and then you can solve for either one of them, really. I would solve for a and get a by itself, so I'm going to divide by b squared. And so 3 over b squared equals a. And the whole reason I'm going to do this is I'm going to take this guy and rewrite it with the same thing. I'm going to put 24 in for f of x. I'm going to put my b to the negative 1 because negative 1 is my x value. And then for my a value, I'm going to use this right here. So my a value is now, I'm plugging this in just for a here. My a value is 3 over b squared. Okay. It looks like a 0, sorry. Let me fix that. There we go. So if I write this out, I've got 3 b to the negative 1 over b squared. And remember, with your exponent rules, division means to subtract the exponents for the same base. So I have 24 equals negative 1 minus 2 gives me negative 3. So 3b to the negative 3. And then I can rewrite this as 24 equals 3 over b to the 3 because a negative in the exponent here. So this negative in my exponent tells me to flip it to the bottom. I can multiply both sides by b to the 3 to get it by itself. Divide by 24. I have b to the 3 equals 1/8. Then just take the cube roots and get b is equal to 1/2. Okay, so now I have all the pieces of b put together, and now I can plug in this b into my a equation up here to get a. So a is going to be 3 over whatever b is squared, and I can pop that into my calculator exactly like it is. 3 over 1/2, oh, typed it wrong, 3 over parentheses 1/2 squared is going to give me 12. 12 is my A. So now I have my A value and my B value to plug into my function. So now the function that goes through these 2 points here in blue will be f of x equals 12 times 1/2 to the x. And then the last part, what is the y-intercept of the function here? And remember, if, that's a big if there, if there is no c value, it's just plus 0 here, there's no c value, my initial value is going to be equal to my y-intercept. So my y-intercept is just going to be 0, 5. Pretty simple, right? And also, you don't have to remember that every time. You can also remember the fact that my y-intercept happens when x equals 0, and I can just plug in c of 0 is going to give me 5 to the 1/8. Oh, let's write that. 1/8 to the 0, which means I've got 5 to the 1 equals 5. So you can plug in 0 for x to get that, or know the rule.